A very good morning to you, Akshat Kapoor, and I welcome you. And here in India, we are at 8 a.m. in the morning. What time is it at Toronto, Canada?
9:30 p.m.
Okay, so I am sure the lectures which we are sending you, you are enjoying it, and I believe
Mhm.
that you will become a good lover of chemistry, and you will start doing a lot of interest and doing more work in chemistry. As you know, what I've been talking last time, chemical reactions. The last time, students, our what we started chemical reactions. Now, when I say students, we told you what we told you. Here is a recap of what we told you, students. We told you there are two types of changes: physical change and chemical change. Two type of changes we see: chemical change and physical changes are those in which identity of the substance does not change. So some substance goes from solid to liquid, liquid to gas, or if I cool the gas, gas will become liquid, and if you further cool the liquid, you can get solid. For example, there are three states of water. Water exists in the liquid which we are drinking, water in the vapor state, steam also, when water evaporates, that's water gaseous state, and ice also. Ice cubes are well known. So these are only physical changes. No new substances have been formed, students, in this case. Water is still H2O. So physical changes you told me last time are reversible changes. They can be reversed. But in chemistry, students, most of the changes which we are studying are chemical changes. That means new substances are being formed. You are burning your fuel. If you have a fuel at home, student, fuel, fuel, what is fuel? There is some gas which you are burning, natural gas you are saying, or liquefied petroleum gas people are burning, or if you have petrol in your car, all these students fuels which you are using. And if you burn them, what happens, student? If you burn them, then some chemical change takes place, chemical reaction, which we will be talking very soon. We already know what are the products: carbon dioxide, water, and energy. Therefore, students, we identified two types of changes, and our main interest was chemical reaction. Chemical reaction. What we are talking is chemical reaction means, students, we told you in a chemical reaction, the important points are there are reactants, students, reactants, and these reactants react to form the products. So we said ki, how do you know these products are new substances? They are new substances, students. Whatever these things were, for example, if I take carbon, students, I react this with oxygen. This carbon was solid, student. Oxygen is gas. You are getting carbon dioxide gas. So here what we are finding that this is different, this is different, reactants are different, products are different. New substances have been formed, students, and when substances are new, their properties are also different. That's very important. In fact, we know most of the reactions which we are talking, student, are chemical reactions. So for example, C6H12O6, this is the formula of the glucose, students, in chemistry. And what happens, students, when it undergoes oxidation, when it reacts with oxygen, then it undergoes a reaction: carbon dioxide, water, and energy. Interesting reaction which is taking place. So we have told you how to balance these reaction. There are six carbon, 12 hydrogen, means there are six H2O, students, and how many oxygens are there? Here you have 6 and 2 8, here 12 and 6 18. So there will be 6 O2. So students, what we are trying to tell you, this is a process which is the result of respiration process. What happens? You are inhaling, you are, students, inhaling air and oxygen gas. So inside the body we have glucose. That is the formula of the glucose. Carbon dioxide is formed, water is formed, energy is formed. Interesting thing was that we said that the chemical reaction should be balanced. Chemical reactions, whatever chemical reactions we write, they should be balanced. Students, can you tell me, students, why the reaction should be balanced? What was the reason that we want reaction to be balanced?
Because of law of conservation of mass.
Excellent answer given by Akshit. You are so good. I mean, you know, law of conservation of mass. That was my point. Student, law of conservation of mass must hold true. Conservation of mass. Okay, then both of us agree that nothing will appear or disappear. But only what happens? Transformation takes place. Or in a chemical reaction, what is happening, students? What is happening in a chemical reaction? For example, if I write H2 plus Cl2 and it gives me HCl, you are saying what you are talking with me, that the number of atoms on the left must be equal to number of atoms on the right hand side. That is what you are saying. Yes or no?
Yeah,
Okay, there can
exactly.
be no appearance or disappearance of atoms. Atoms are only being exchanged in a chemical reaction. What is happening? They are being, so number of atoms of each substance, let us say each substance or reactants, these are the reactants, so must be equal to number of atoms of each element or substance. We are saying each number of atoms of each element in the product side, products. So this is has to be there because the law of conservation of mass will only hold true if it is there. So we said, okay, we balanced, and we have shown you some of the methods to balance the reaction. The question is still there, students. If I write a balanced reaction, if I write a balanced reaction, for example, if I have written, you can take any example of that. Last time we have given you a reaction in which we said iron reacts with water and the product was Fe3O4 and hydrogen. We wrote it like this. Then we balanced it. How was it? 3Fe, 3Fe, 4H2O, and then how many hydrogens will be there, students? 4H2. Is it balanced? Tell me, is it balanced? Is the number of atoms on the reactants
Um, for 3 iron, 4 oxygen, and yes, it's balanced.
balanced?
Yeah,
Okay, very good. Keep on interacting with me. Keep on. Our energy level should be high when we are learning the things, because our interaction is 1:1 students. We are live class, taking live classes with all the students. They can ask questions. They can ask us their doubts or any difficulty, any problem. You can ask me anytime. But this is still not complete. You know what is the problem with this? What is the problem with these students, that we have not written the physical states? Next thing is we should write the physical states, physical states of the reactants and the products. So if I carefully examine, I don't know iron is in which form, solid, liquid or gas. Water is in which form? There are three states of water, solid, liquid or gas. This, what is this state? Solid, liquid or gas. What is hydrogen? Gas, solid or liquid. So we must
yeah.
be able to write the physical states of the reactants and products in a chemical reaction. What I am trying to tell you, students, that we want to have more information about the chemical reaction. And for this, what we do, students, we specify the physical state. The physical state, you know what type of physical states we have? Solids, they will be represented by small s. Liquids, in chemistry we write L. Gas, you will use G. And things which dissolve in water, students, lot of substances are in water. So there, what we are saying, for example, you put sodium chloride in water, you put HCl in water. So when you are putting or dissolving students in water, then what we write? Aqueous. And the symbol which you use is AQ. If I write HCl aqueous, that means this is HCl, it dissolved in water. It is present inside the water. If I say C2H5OHL, that means it is a pure liquid. It is a pure liquid. This ethanol is a pure liquid. L is a pure liquid. If I say H2L, that means it is a pure liquid, pure water. And if I write something like CH3COOH aqueous, that means it is a liquid but dissolved in water. Got the difference?
Yeah.
So when we will have pure liquids, I will represent by L. If they are in water, I will represent by AQ. AQ mean aqueous will be used a lot. Student, aqueous will be used a lot. Therefore, students, we are trying to say now the reactions should be more informative. And for example, now I am saying 3FeS reacts with 4H2O. Actually, you will find that iron does not react with water under ordinary conditions. If I have iron put in water, it will take a lot of time. There is no reaction as such. Very, very slow. So what we do, heat it. So as you will start heating, students, the iron will react. Iron reacts with what? It does not react with liquid water. It reacts with gaseous water, I'm saying. So I have now specified the state of the reaction. If I take iron and H2O liquid, reaction, no reaction. But if you boil the water, steam, this is water vapor, it reacts with iron. Got my point?
Yeah.
So what is the product then? You will get Fe3O4. Then I must write that this is solid and you are getting 4H2 which is in gas state, students. Now this reaction is more informative. Sure, you have got the states of the reactants: solid, gas. So it has more information. Yes or no? Tell me.
Yeah. Yeah.
Okay. Whenever there is a gas, we represent an arrow like this. That means gas, what happens to the gas? Gas will escape, gas
Yeah.
will move to the atmosphere. Solids will move inside the solution. Gas will move up. So they can represent an arrow to show it is gas. I am saying it is still not complete. Why it is not complete? Tell me what else you want to know from me for a chemical change. This is a chemical change, this is a chemical reaction. But do you think in chemistry you will find there are certain conditions of every reaction? There are conditions of reaction, yes or no? Certain
Yeah.
things react with air and catch fire, but in other cases you have to heat them, then only reaction takes place. Right or wrong? Cold
Yeah.
cold condition reaction doesn't take place. You heat,
Yeah.
reaction takes place. You have
Yeah.
seen in chemistry lab they have a lot of heating burners. Why? They will heat. Okay, you are saying on heating reaction takes place. You are cooking your food, what you are doing? Heating.
Yeah. Peter.
That is a chemical change is happening, chemical process is happening. When you start heating, new things are being formed, new substances are being formed, students. Therefore, student, usually what is the important? We need to know the temperatures. There is temperature is very important, which is expressed in, I said T in Kelvin usually. Kelvin is the SI unit of temperature. SI unit of temperature. And in many reactions, they will show the pressure P. At what pressure the reaction takes place, student? You are at 1 atmospheric pressure. You know, air has a pressure, air has a pressure. But when reaction takes place, they may need very, very high pressure, students, very, very high pressure. So we will have to mention pressure in supposing atmosphere or some unit, bar. How many bar is there? How many atmosphere? These are the units of the pressure. Therefore, students, some reaction takes place in the presence of light energy. Light energy. You know, sunlight.
Mhm.
Certain reaction may take place in the presence of light energy, I am saying. Certain reaction may take place in the presence of UV light, ultraviolet radiation. So, certain reactions, you are saying electrolytic reactions, electrolytic decomposition or reactions. Are you aware of all this?
Yeah.
Some reaction takes place in the presence of light. Some you pass electric current, electricity, and decomposition takes place. Electrolysis, electroplating, all these reactions are taking place when you are passing electric current. So sometimes also you have seen reactions need catalyst, students, catalyst. Can you tell me what is a catalyst? You have any idea about catalyst, Akshat?
Um, it's something that speeds up the process of the reaction.
Yes, students, you know, inside your body are also catalysts. Do you know which catalysts are present inside your bodies? Enzymes. What they do? Are you are eating your food. There are enzymes in the body. They are like protein molecules. They will catalyze the digestion of the food. Your food is digested 2 hours, 3 hours, or whatever process is. If these enzymes are not there, food cannot be digested. You put a piece of bread outside your home, don't use it. After a few days, what happens? It will start having some problem, fungus or something. It spoils. But inside your body, the food is being decomposed into glucose, and glucose is going into carbon dioxide, water, and energy. So there are enzymes, student, there are catalysts which are doing this. They increase the speed of the reaction so fast that we are able to live and digest our food. If there are no enzymes, food will not be digested. And what will be the result of that? We won't be here then. We will die in few days. See, the story is like this. The reaction is still not complete, I am saying. Therefore, you are saying we have to give more information for the reaction, students, in order to make them complete and give them more information. For example, in a reaction, I am talking of a reaction where I am preparing, student, methanol. This is our methanol, student. This is a liquid and this needs 340 atmosphere pressure. So we write on the arrow, student, on the arrow I have written 340 atm. That means this is the pressure which is required to convert carbon monoxide gas, hydrogen gas into alcohol. This is my alcohol, methanol. This is a alcohol, student. It is called methanol. L means it is a liquid, this is a gas, this is a gas, but this reaction will take place only if this much pressure is given to the two. You know, gases, they are compressed at high pressure, high pressure. So I have to mention the conditions of the reaction. If I am saying this reaction is taking place, students, 6CO2, 12H2O, students, liquid, photosynthesis reaction, photosynthesis reaction, students. Plants make their own food, yes or no? But
Yeah.
we have to grow the food. We don't prepare our own food inside our body. We are eating food from outside. Whatever carbohydrate, fat, proteins, whatever you are eating the whole day, veg, non-veg, all cheese, milk, everything we are eating. Animals also are eating. They have to be feeded students. But what is to the plants? What is the plants are doing? They are taking carbon dioxide and water, which is also present. You are watering the plants, watering the plants. What happens then? That you are saying they are preparing what is the reaction C6H12O6. This I am saying aqueous means it is dissolved in water. Aqueous, this is a glucose, and they are producing oxygen gas, students, and water liquid. So this is my glucose. This is the photosynthesis reaction, how the plants are preparing their glucose, and they are releasing oxygen gas and also producing water in the process. But this reaction needs sunlight, and there is a catalyst, student, which is called chlorophyll. That green color substance, then only this reaction takes place. If the sun is not there, what will happen? If sun disappears, the result is there will be no photosynthesis. And what will happen? This process cannot take place. Therefore, students, what I have tried to show you, that there are conditions which must be mentioned for to make a reaction complete, student, in order to show that reaction is complete. Okay. Any doubt?
No.
Okay. Next, students, I am moving to two types of reactions are known. Exothermic reactions. What are exothermic reactions, students? You know, when reaction takes place, sometimes the solution becomes hot. Heat is evolved. In large number of reactions, it will happen like this. Heat is evolved, students, in many reactions. We are saying heat is evolved. Such reactions are called exothermic reaction. There is a energy which is released. Just now we have shown you the glucose, the food which you are eating, students, C6H12O6. This is your glucose which is inside your body. What is happening? It is reacting with oxygen gas. You are saying it is producing carbon dioxide, 6H2O liquid, and it is giving heat. So this is an example of what type of reaction is this? Heat is evolved exothermic reaction. This is example of exothermic reaction. If no heat is evolved, no energy is liberated, then how will I work? What do you mean by it is a fuel for the body? This is a fuel, student, for the body which we have. How do we get energy, students? How you are getting calories? What you are talking of calories? That's the heat which is liberated during the process. So whatever you are eating, it is undergoing chemical process, and what you get from these carbohydrates, these are called carbohydrates, sugars, glucose, energy, heat energy. So these are examples of exothermic reaction, students. This is a, then you can take, this is our quick lime CaO. These are examples, student, examples of exothermic reactions. If I take quick lime, I react with water, student. I put quick lime in water, what happens? It produces calcium hydroxide, and the result is lot of heat is liberated. This reaction liberates a lot of heat. So these are all examples of, this is called quicklime, this is called lime solution, which is used for whitewashing. Then it can combine with carbon dioxide to form a layer of CaCO3, CaCO3. So students, this is called slaked lime. These are all examples of reactions in which heat is liberated. There are second type of reactions which are called endothermic reactions. Endothermic reactions are those students in which heat is absorbed. There are reactions which will absorb heat. For example, you have CaCO3 solid. If you give heat, if you heat it, student, it will decompose to give. This is an example of decomposition reaction. So here heat is absorbed. If you want to decompose it, students, heat is absorbed. And this is called endothermic reaction. Endothermic reactions. So all those reactions in which heat is absorbed are examples of endothermic process. So what we say, this is our respiration. This was our respiration, students. I can say respiration is an exothermic reaction. Is an exothermic reaction or exothermic process. So here heat will be evolved, and that is the reason when you eat your food, as it gets digested, energy is released. So you are getting two types of reactions, student, exothermic and endothermic reactions. Always we will find there are two types of the reactions. Any doubt here?
Um, so endothermic,
Reactions
you
are
start
those
off with
in
heat.
which heat is absorbed. Unless you give heat to this, if I say,
Uh,
for example, KClO3 solid, I will
yeah.
give heat, then it will decompose to give
So
last
it
three.
absorbs it. It absorbs heat, or
So
does it?
there is a absorption of heat, absorbed. The reactants absorb heat, then the reaction takes place. And
Okay.
here reaction takes place, heat is produced. Heat is produced.
So it gives out heat.
Yes. So
Okay.
then these are very important reactions because we can use this heat. Combustion reaction, fuel. What the fuel does? You are burning the petrol inside the car. In the engine of the car, petrol is burnt, which produces energy. Energy means heat. That is used for running the car, student.
Hmm.
You are making your food at home, gas. You are burning a gas. What the
Yeah.
gas is giving? Heat energy. So exothermic reaction. There are examples of combustion reaction, students. All fuels burn and produce energy or heat. Heat and energy, they are the same things. So there are two types of chemical reactions, exothermic and endothermic reactions. Okay, you can note down. We will give you more examples of that.
Okay. Got it.
All right.
Thank you.
Further, we are saying there are different types of chemical reactions. Students, types of chemical reactions. Now we know how to write a chemical equation. We know how to balance a chemical equation. We know how to specify the physical states, solid, liquid, gas, aqueous. We also know on the top of the arrow, we are writing catalyst or we are writing temperature and pressure. So we are giving a complete information about a chemical reaction. But there are different types of chemical reactions which we will experience in our everyday life. First one, combination reactions. combination reactions. Students, what do you mean by combination reactions? Combination means what? What do you mean by combination? So, things are combining, reactants
Yeah.
will combine and form a product. Reactants will combine and form a product. How will they combine? You said carbon, oxygen gas. What happened? They formed CO2 gas. So 1 plus 1, these are two reactants. They have combined to form one product. This is an example of combination reaction. Students, combination reaction means that two or more substances, combine to form, they are combining to form, students, single product. Single product. ठीक है? You can have many examples of this where such combination is possible. For example, if I said CaO quick lime, this is a quick lime. This is a solid, student. It reacts with water liquid and it forms CaOH twice aqueous plus heat. So these two combine to form one product. This is an example of combination reaction. Also heat is liberated. Therefore, this is an exothermic reaction. In this reaction also heat will be liberated, student. All the combustion reaction produces heat. You burn coal or any gas, what happens? Heat will be produced. That heat we can use for any heating purpose. Any heating purpose. So here was the first example, students, where combination has taken place. Then students, we can have decomposition reactions. Decompo Decomposition reaction, students. What happens? You decompose a reactant into two or more products. You will decompose a reactant into two or more products, students. I said CaCO3 solid. Heat it. What happens? It produces CaO plus CO2 gas. Here you can see that decomposition has taken place. Decomposition has taken place, student. Single reactant. This is my single reactant. It breaks down into two or more substances. More substances. So I have given heat to it. On heating, it decomposed. Students, on heating, it decomposed. This is called this is called thermal decomposition. Thermal decomposition. What is the meaning of thermal? Heat
Heat.
something, it will
Yeah.
decompose. Large examples are there. When you will heat, they will decompose. Such decomposition is called, in the decomposition, I am saying thermal decomposition means decomposition by heating. Decomposition by heating. This is the first one. Have you noted it?
Yeah.
Any doubt?
Um.
I will
So
give
when we
more
decom.
examples of this thermal decomposition. I am giving more examples.
Okay. So there's different types of decomposition.
Okay, here are more examples coming. You see that there is a ferrous sulfate. This is a ferrous sulfate. There are 7 water molecules. This is a ferrous sulfate, student. FeSO4, 7 water molecules. What happens? I heat it, it will form FeSO4 plus 7H2O. Now this has water, the water is lost. Water is lost on heating. ठीक है? And what will happen? There will be change in color. Further, you further heat it. You heat it more, students. And what it will form? It will further break down. It will further break down into Fe2O3. You further heat it, Fe2O3, SO2, and SO3 gas, students. So this was solid, this is solid, this is liquid, this is gas. So here we have heated it, and on heating, student, it breaks down into two or more than two substances. It breaks down into two or more than two substances. So this is called thermal decomposition. These are all examples of thermal decomposition, student. Thermal is a word which is used for heat. Heat it, then you will. Another example, you can take lead nitrate and heat it. Lead nitrate powder and heat it, students. Heat it, student. Formula of lead nitrate is PbNO3 twice. If I heat it, students, then what will happen? It will break down to give lead oxide. This is a solid. There will be a gas, student, NO2 gas, and there will be oxygen gas. So this breaks down, student. You are getting this is a nitrogen dioxide gas. Nitrogen dioxide gas, student. So there will be fumes of, this will be brown fumes. This is brown in color. So you take a test tube, take some lead nitrate, heat it. What will happen? You will see brown fumes coming out. What are the brown fumes? That is nitrogen dioxide, student, NO2. These are examples of, students, thermal decomposition. Can there be any other type of decomposition? Have you heard about any other decomposition, students? Have you heard about decomposition by passing electric current? Tell me.
No. No.
Electrolysis. Electrolysis. What is electrolysis? Can I proceed further, or you want to note down?
I in the Let's cover this.
Okay, note down. Then I will proceed further.
Okay, you can keep going.
Okay, we proceed further, students. The second type of decomposition is used a lot, student. That is called electrolytic decomposition. You have heard about electrolysis of water. Water, student, water, if I do the electrolysis of water, it will decompose, students. Water will decompose on electrolysis. What will happen? This is water. I am doing electrolysis, and this will produce, student, hydrogen gas and oxygen gas. So if I take two of this, then you have, this is our liquid. You will get hydrogen and oxygen gas on electrolysis. What we are saying, what we do, students, you can have an apparatus like this. Students, this is our water. This is my water, students. And I have here two electrodes. For electrolysis, I will need electrode, student. You know how we do it. This is a key, and that we have to attach a battery, student. Battery. This is a battery. Here you can attach a battery of supposing 6 volt. 6 volt battery. So students, what will happen? This is my water. These are called electrodes. This is our key. I will take the put the insert the key. Current will flow, and electrolysis will take place. Electrolysis will take place, student. Water electrolysis will take place, and water H plus and OH minus ions. What will happen? You have to H plus 2E. Hydrogen gas will be liberated, student. And if you have OH minus, student, what it will give? O2 gas and H2O. So there will be H2O and oxygen gas, and this will give you electrons. These are some of the ways we are representing. So there are two. What I have said, this is only to show you that when I will do the electrolysis of water, students, it will dissociate. This will be called electrolytic decomposition. I have passed an electric current, then only decomposition takes place. So battery is supplying electric power to it to break down the water into two or more substances. These are all examples of decomposition reactions. But I have told you decomposition can be done by heating, by passing electric current. This is a second case, which we are called as electrolysis. This is called electrolysis. Any doubt here? You can
I
take
know.
water
Okay.
and pass electric current. It will break down and produce two gases, hydrogen and oxygen. This reaction, this is will take place at the cathode. This will take place at the anode. There are two electrodes. One is cathode, other is anode. We will learn more in this electrochemistry chapter, how the electrolysis takes place. So there will be bubbles. You see inside this, you will see bubbles of the gas coming out. What you will see, students? You will see the gas bubbles coming out. These are the gas bubbles. And here also you will see gas bubbles. Which gases are coming out, student? Hydrogen gas and oxygen gas.
Okay.
So this is called electrolytic decomposition, students. And another type of decomposition, you are aware of photography a lot. Photography, how you they develop photographic film. Light energy falls and you get pictures, students. So light energy is also important, student, that we can have photochemical decomposition. Photochemical decomposition, students. That means you will pass light energy, the substance will break down. Do you know any example of that, students? Have you seen it? For
No, I've
example,
never seen photon before.
silver chloride, student, AgCl. What happens, students? This is white in color. And if you expose it to sunlight, it will dissociate, students. It will dissociate to form silver and chlorine gas. And chlorine gas, students. So this is gray in color. There will be change in color. You can use AgBr, that will also need sunlight, student, and it will break down into Ag and Br2. So see that the color will change. The color will change, students. These are the examples. These are all the examples of decomposition. But the decomposition is happening by light energy. Light energy. So these are called photochemical decomposition. When decomposition by heating, thermal, decomposition by electricity, electrolysis, decomposition by light energy, photochemical decomposition. Any doubts here?
No, no, no. Good.
You can note down, very important.
Yeah.
Different types of reactions, different
Yeah.
types of
Give me two
reactions which
seconds.
we are talking. Chemical reactions are of different types.
All right. Good. Good.
Okay, then I will proceed further, students. Now, another type of reaction, students. We have told you combination reaction, decomposition, and third reaction is called, student, displacement reaction. What is a displacement reaction, student? Displacement reaction. What do you mean by displacement? One element will displace another element. One element will displace another element, student. For example, here is my test tube, student. Inside this, I have copper sulfate solution. This is blue in color. Copper sulfate is blue in color, students. And I put an iron nail. Iron nail. FES. Inside this, what will happen? Now I'm putting, students, this is my iron nail inside this. What will happen? What will be the result of that? That's my iron nail. After some period of time, you will find what you will find. Blue color of copper sulfate, students, fades slowly and slowly disappears. Disappears. And on the surface of iron, you get a coating. You get a coating, and the color of this changes. What has happened, student? Iron, copper sulfate, aqueous. Iron displaces copper. Fe displaces Cu. Then what will you get? FeSO4 plus Cu. So this Cu will get deposited on the surface of the copper, iron. So this has a gray color. Copper has a gray color. Therefore, students, the result will be, this is an example of displacement reaction. This is also called single displacement reaction. More active metal displaces, more active metal displaces less active metal. The more active will displace the less active metal. Here, iron displaced copper, but copper cannot displace iron. Why? Iron is more reactive than copper. What we are saying? Iron is more reactive than copper. Iron is more powerful. It will replace this copper from solution of copper sulfate. The result is this chemical reaction will take place, and this is known as, students, displacement reaction. Displacement reaction. Other examples of this: zinc is more reactive than copper. Then what will happen if I put zinc in copper sulfate solution, students? What will happen? This zinc will displace copper, and you will get ZnSO4 plus copper, students. So there will be change in color. This is blue, this is white, colorless. This was blue in color, student, but this will be colorless or white. White we call as colorless in chemistry. Colorless solution will be there. See, the reaction is taking place, students, but more active is displacing the less active from the salt solution. From the salt solution. Such reactions are called displacement reactions. ठीक है? Got it? Any doubt?
Got it.
There is a reactivity series which have been given in the book. Reactivity series means which metal is more active than other. The only thing we must know is more active metal will displace the less active metal. Because it is more powerful, it will displace the less active metal. Such reactions will be called, student, single displacement or displacement reactions. Further, what else can happen? Another reaction is called double displacement reaction. Double displacement reaction, students. What happens if I have, students, a solution of silver nitrate aqueous? I put it in a solution of sodium chloride aqueous. What happens? You get AgCl solid and NaNO3 aqueous. What has happened, student? In this, what has happened in this reaction? What has happened in this reaction? Let me see. I will say these are ionic compounds. Ionic compounds. How do I write the ions? There were these ions. What are the ions which are present in this? What happens? Plus ion of this is a plus ion of this will go with the negative ion. If plus will go with the negative ion, student, what will be the result of that? AgCl. This is a solid. And what will happen? It will settle down. Solid will settle down, student. This is called precipitate, student, precipitate. Such reactions are called precipitation reactions. This is a white colored solid which will come in the test tube, and this now, this is negative, this will go with this positive. What will be the product? NaNO3 aqueous, students. Therefore, students, This type of reaction in which there is an exchange of ion student, exchange of ion student is known as a double displacement reaction. These are examples of double displacement reaction. Such reaction in which there is an exchange of ions, reactions in which there is exchange of ions students between the reactants are known as double displacement reaction. This is called double displacement reaction, student. And any doubt, students, here what I said? Sodium sulfate. Sodium sulfate solution, students. Another example. When it is reacted with barium chloride, it is reacted with a solution of barium chloride. What happens? What happens in this case? There will be a double displacement reaction, student. A double displacement reaction will take place. After you note it down, I will go to the next page.
Okay, got it.
I'll go to the next slide after you are finished.
Okay, I'm done. Yeah, good.
Okay. I'm saying sodium sulfate. What is the formula of sodium sulfate, student? Na2SO4. This is sodium sulfate. It reacts with barium chloride. What is the formula? Barium chloride, aqueous. Aqueous. And the product is barium sulfate. This is a solid barium sulfate and NaCl, aqueous solution. What has happened? I said there is an exchange of ions. Exchange of ions between the reactants. Between the reactants. What it means? What are the ions in this case? These are the ions. What are the ions here? There are two ions, barium plus and chloride minus. Exchange of ions. This negative will go with the positive of this, and this positive will go with the negative of this. Then what will be the product, students? Sulfate and barium. But you are getting barium sulfate. Sodium and Cl minus, sodium chloride. Is example of, students, exchange of ions. Tell me, is it exchange of ions or not?
Um, yes.
This is called double displacement reaction, student. This will be only when there will be ionic type of substances. They will easily form ions in the solution. What happens? As soon as you put sodium sulfate in water, it forms ions. This will also form ions. So opposite ions will attract. Opposite ions will attract and form the product. Students, this is a solid. So this is also example of precipitate. There will be a precipitate, students, of barium sulfate. This is a solid. So I'm showing it an arrow like this because it settles down. Precipitate will sit down in the test tube. So what we are saying, if you have a test tube, students, and what you are having inside this, Na2SO4 plus BaCl2 aqueous. Then you will be able to see, students, a solid coming out, which will be barium sulfate. This is a precipitate. This is called precipitate. So that will settle down. This is an example of, what is this? This is an example of what we call as double displacement reaction, students. Any doubt?
Hmm?
Any doubt to
No,
you?
no, no, no doubt, no doubt.
Okay. Further, we are talking of oxidation reactions. What is the meaning of oxidation, students? What is oxidation? Addition of oxygen. Addition of oxygen is called oxidation, students. If I take copper and heat it with oxygen, heat, then what happens, students? You get copper oxide. This was my copper, and you are getting copper oxide, students. This is black in color. Black in color. So what is that? There is a change in color, student. Here color has changed. So this copper powder is getting blackish. Blackish. Copper color is almost something like gray color. So you will see some black powder formation. So copper has been oxidized. Addition of oxygen. This is called oxidation process, student. Therefore, we say that in this reaction, copper is oxidized to CuO, and we will see a color, black color formation in the reaction. Black color formation in the reaction, students. There is also reduction reaction, students. We can say addition of oxygen or removal of hydrogen. This is called oxidation. Reduction reaction means removal of oxygen. If oxygen is removed, student, then what we say, reduction has taken place. Oxygen is added, oxidation. Oxygen removed is reduction. So what we can do, if I take copper oxide, student, and heat it with H2 gas, what happens? You will get Cu plus H2O. This copper oxide is converted into copper, students, on heating. This is my hydrogen gas. This is my solid. This is my solid. This is my liquid. So what has happened, students? What has happened in this reaction? Copper oxide is reduced. Copper oxide is reduced to copper. To copper. So there will be again color change. This is blackish color. This is gray in color, students. These are examples of oxidation and reduction. Oxidation and reduction. And what has happened, student? Such reactions are called redox reaction. Redox means reduction and oxidation takes place. Reactions, student, reactions in which oxidation and reduction takes place. And reduction takes place are called redox reactions. Such reactions are called redox reactions, in which both oxidation and reduction takes place. Both oxidation and reduction always. There can be no oxidation without reduction. There can be no reduction without oxidation. That's what we are saying. One substance is oxidized, other is reduced. For example, in this reaction, what has happened, student? If I say CuO plus H2 gas, it gives me Cu solid plus H2O, H2O supposing this is a liquid. Then copper oxide is reduced and hydrogen is oxidized. Got it? This is
Yeah.
addition of oxygen, oxidized. Removal of oxygen, reduced, reduced. And here hydrogen is reduced and copper is reduced, copper is reduced, copper is reduced. This is reduced copper oxide. So copper oxide is reduced, student. Then the substance reduced is called oxidizing agent, and the substance, students, oxidized is called reducing agent. It's called the reducing agent. Got it? Is
Yeah.
it
Got it.
clear?
Yeah. I'm just writing it down.
Okay.
Okay.
Another
Oh, it's
example.
10. It's 10:35.
If I say ZnO with carbon, what happens? Zn plus CO. You will get Zn plus CO. This is my gas. Solid, solid zinc oxide. So this zinc oxide is reduced. Carbon is oxidized. This is my carbon monoxide. Carbon is oxidized. So I can say carbon is acting as a reducing agent and ZnO is acting as an oxidizing agent. These are the examples of oxidation and reduction. So you can note down, students.
Mhm. Also, it's 10:38, so it's been 1 hour.
Yeah, the substance which undergoes oxidation will be reducing agent. The substance which undergo reduction will be oxidizing. Because one will be oxidized, other will be reduced. And we call these reactions as redox reactions. These are examples of redox reactions. All these are examples of redox reactions. Everything is clear, students?
Yep. Got it.
Okay, then we will take leave for this today class. We have discussed with you what are the different types of chemical reactions, and we will, I hope you have understood and enjoyed the session. Bye bye. I will meet you in my next class.
All right. Thank you.
Take care. You are
All
going
right.
to sleep and I am going to work. It's the morning
Mhm.
for me and you will be sleeping in Toronto, Canada. Bye bye. Have a good sleep. We will meet you in the next class.
All right. Have a good day. Bye.
Okay, take care.